So as we start in with solving equations with variables on both sides, I've already kind of introduced it a little bit, um, but now I'm going to give you some actual step-by-step on how to, and we're gonna dive in today a little bit more into that. So in order to solve equations with variables on both sides of the equal sign, follow these steps. So here we go. First thing I want you to do is I would like you to distribute to get rid of the grouping symbols. Which you know hopefully that means parentheses. And the next thing we're going to do is we're going to simplify both sides of the equation. So simplify. And I want you to simplify both sides of the equation separately. What I mean by that is combine like terms. Sometimes I talk about it in class like as packing things up. So we're going to distribute and then we're going to pack things up. And then after that, we're going to move. I'm going to have you move the variable terms to one side of the equal sign. And I want you to do that by basically you're moving them across by addition or subtraction. Add or subtract to move, add or subtract to move across. Right? Then, after we move all of the variable terms to one side, we're going to move the constants terms, the constant terms, to the other side of the equal sign. And again, add or subtract to move across. The fifth thing we're going to do is we're going to use the properties of equality. And when I say that, meaning you're going to do it to each side. So to solve the problem. So we know that it's addition and subtraction, but then we also know multiply and then divide, or vice versa. The last thing we're going to do is we're going to state the solution. Oops, I should switch colors. I've been doing a pretty good job of that. State solution. And I'm going to add a seventh one for you. The seventh one I'm going to add is going to be check your solution. You should never have an answer that you don't check, because when you check it, you can guarantee you're correct every single time. So make sure you plug it back into the original problem to see if it works. So check your solution, plug in your answer to the original problem and check. simplify. It'll prove whether it's right or wrong. So with those steps, now we're going to start out with example number 1. Example 1, line down the middle. I suggest you move your variables to the left because it's kind of a constant way of doing things, kind of keeps you in the rhythm, a nice process. So here I don't see any parentheses, so I don't have to distribute, but I'm going to move my variables to the left. So add 2k, add 2k. Now I have 9 minus 1k is equal to 17. So I move my variables. Now let's move those constants. Take away 9, take away 9. So negative 1k is equal to 17 minus 9 gives me 8. And divide by negative 1. So k is equal to negative 8. Did I miss something up here? Maybe I did. Let's go back. Boom. Let's scroll down. Oh, yeah. You're not here to tell me. Here's this first one. Let's go ahead and do it. I jumped right in, didn't I? This one, I'm going to put my line down the middle. Move my variables to one side. So I'm going to go minus the 3m. Minus the 3m. So I end up with 24 minus 6m equals 2. The next step, I'm going to take away 24, take away 24. This one I end up with negative 6m is equal to negative 22. And divide both sides by negative 6. Now I know that when we have an inequality, we have to worry about that, but not with an equality. So I'm left with m equals negative negative is a positive, and 22 divided by 6. I could reduce that to 11 over 3. Which is also approximately 3 2/3, which is approximately 3.6 repeating. So actually this would be an equal. That's an exact value. And then it's approximately 3.6 repeating. B, line down the middle. Take away 4x, take away 4x. Move those variables to one side. So 20 minus 3x equals 7. Take away 20. So I end up with negative 3x is equal to negative 20 minus 7 is 13. Is that right? Now we have a problem. Let's redo this. I'm looking at my problem here and I see I have two equal signs. Let's make this a negative 7 right here. There we go. Now that's a negative 7. That makes life so much easier. Line down the middle here. That's a negative 7, so I can go minus the 4. Oops, excuse me, minus the 4x. Let's keep on going here. Minus the 4x, minus the 4x. There we go. So 20 minus 3x is equal to negative 7. Take away 20 from both sides. Now we have negative 3x equals, bring it on down, negative 27. Divide by negative 3 on both sides. X is equal to 9. The following one, number C, we already did. So if you need to pause and make sure you have it written down, or you can pause it and like not look, try to do it on your own, and then go ahead and write it. D, we're going to start in with a step 1 distribute. So we have a distributive property. So 5z minus 2 is equal to 6z minus 2 times negative 4 is negative 8. Line down the middle, move your variables. So negative 6z, or subtract 6z. I'm left with negative 1z minus 2 is equal to negative 8. Add 2, add 2. Negative 1z is equal to negative 6. And divide by negative 1. Oops. So z is equal to negative and negative is a positive, and I get 6. So the next one has some fractions in it. I like throwing those at you just a little bit to see if you guys can handle them. I'm going to show you, you can't just multiply by the reciprocal on this. We actually have to distribute it. So as we distribute this, I'm going to have you multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. So 8y minus 6. The game is on, and I'm trying to do notes. So you're going to have to excuse any words that you hear. Hopefully you're not hearing any words, but we have some cheering in the background. So let's pause it just a moment. Let me have the cheering. All right. So anyways, that was an interception. So here we go. We're going to just distribute this 2/3. So I'm going to multiply by the 2 and divide by the 3. So 2 times 6 is 12. 12 divided by 3 is 4. So that's 4y. Multiply by the 2. So 2 times 15 is 30. Divided by 3 is 10. Multiply by the top, divide by the bottom. Now, I have my equal sign here. Move my variables to the left. So take away 4y. Take away 4y. I end up with 4y minus 6 equals 10. The two-step equation, or remove your constants over. So add 6, add 6. 4y is equal to 16, and divide by 4. Y equals 4. And again, you can double check it by plugging in a 4. 4 times 6, add to 15, take 2/3 of it, or multiply by 2, divide by 3. Also put the 4 in over here. 8 times 4, 32, take away 6, and they should be balanced. The next one, distribute the 9. So I have 9z plus 12 equals 9z plus 27. Line down the middle. I'm going to take away 9z, take away 9z. We have a special case right here. Oops, let's put a little star by it. Whoop, whoop. All right, little info here. We end up with 12 equals, those cancel and cancel equals 27. Now this is a false statement. So no variables left. And it's a false statement. Okay, this means no solution. Okay, meaning nothing you put in there is going to make it work. No variable that you can plug in for z is going to make this work. So it's no solutions, false. So no variables, false statement, no solution. Next one, line down the middle. Dang. All right, so now I'm going to move my variable to the left. So take away 8w, take away 8w. I end up with negative 1w plus 1 is equal to 1. Move your variables across. At any point in time, you can pause me and try them on your own, of course. So take away 1, take away 1. Now I end up with negative 1w is equal to 0. Now I still have a w. Negative 1w is not 0 times w, so negative 1w. So divide by negative 1, divide by negative 1, w is equal to 0. I still have a w, so it is a valid number. So 0 is a valid answer. 0 is a valid value. Okay, so don't just get the 0 and go, "Ooh, I'm done." Okay, it's a value, it's a valid number. So here I am. H. This one has some distribution on both sides. I'm kind of mixing it up here a little bit. So 2 times 2x is 4x. 2 times negative 4 is negative 8. Equals half. Multiply the top. So 1 times 8 is 8 divided by the bottom 2. So 8 divided by 2 is 4x. 1 times negative 16 is negative 16 divided by 2 gives me negative 8. Now this one, when I move my variables, negative 4x, my x's all go away. So x's cancel, or give me 0 x's. But I get negative 8 equals negative 8. This is true. So if my x's cancel and it's a true statement, this means all real numbers. It has infinitely many solutions. Okay, so infinite solutions. All right. So another way to say it would be infinite solutions. You can say all real numbers, or you can say the capital fancy dancy R for all real numbers. Those are our three special cases. So if I were you, I would put a little box around these, because these are the ones you're most likely to like not remember what to do. 0 is a valid number, so this is okay, but these two are the specials, no solution and infinite many solutions. All right, so the next part, we can think before we solve a little bit, or we can use a distributive property. Either way, and distributive property is just fine, but if you can think before you solve, it might make life a little bit easier. So distribute, you can always do distributive. So if I distribute, it's going to be 2x minus 6 equals 14. Add 6. 2x is equal to 20. Divide by 2. X equals 10. However, if I have x minus 3 equals 14, and I were to say divide by 2 without distributing, because 14 is divisible by 2, I'd have x minus 3 equals 7. Add 4, add 3, add 3, I get x equals 10. So either way you choose. I will tell you that number 3, my answer is x equals negative 8. Number 2, x equals negative 7. Number 4, x is equal to 60. And number 5, x equals, I think, 44. So try those 3, try on your own, and then ask me for help. Ask for help. The last one is an equation. I'm going to say a family of 6 is going to the fair. They have a coupon for $1.50 off each ticket. But they pay $46.50 for all their tickets, so that's total. How much does each ticket cost without a coupon? Explain and show your reasoning. If you get stuck, try on your own. Think about algebra, setting it up. We are working with some parentheses. Label your variable, do all of that. There's should be room at the bottom of your page. Example 2. Example 2, I have solved the inequality. If possible, so we're going to work with inequalities. Again, here's some distributive property. Because I have a binomial over here, 2 things, so I can't just divide by 6. So I'm going to have 12x minus 1 is greater than 12. Oops, make that pretty. 12x minus 6. So this one, I line down the middle. I'm going to take away 12x from both sides. And I end up with negative 1 is greater than negative 6. Now, it all canceled out. So my variables canceled. Oops, canceled. But it's a true statement because negative 6 is bigger than, or negative 1 is bigger than negative 6. So it's true. So if it's true, it means all real numbers. So to graph that on a number line, it would be the entire number line. Everything is a solution because it's all real numbers. The next one, I'm going to distribute. Let me get 14x plus 5 is less than 14x minus 21. When I take away 14x, yeah, 5 is less than negative 21. Oops, negative 20. Negative 21. This is a false statement. So variables canceled. Canceled. So I know it's special. Special. So the variable's canceled. It's a false statement, which means no solution. Okay. So you don't even have to do anything on the number line. You can just basically no solution. Doesn't work. Concept 2 of inequalities here. I'm saying that the gas station charges 10 cents less per gallon of gasoline if a customer also gets a car wash. What are the possible amounts in gallons of gasoline that you can buy to also get a car wash and that you can spend at most $20? Well, what I can spend is going to be at most, so less than or equal to $20. And that's the first part. That's the inequality part. Now I want you to think about, what is that value? Well, the gas value is 209. If I also get a get a car wash, it's going to be this much. So basically I have 209 minus the 10 cents per gallon plus the $8 wash. And now I can solve it. So 209 minus 10 cents gives me $1.99. Plus 8 is less than or equal to 20. Take away 8, take away 8. So I get 1.99. X is less than or equal to 12. Divide by $1.99. And this would be the gallons, number of gallons, right? Equals X. So there's my label. Here's my equation. Here's my solving. X is less than or equal to, and I believe it's 6.03 gallons. So with a car wash, I can buy up to 6.03 gallons of gas and get a car wash for 20, up to, so up for $20. Boom. And that's it.